everyone, I'm Yuan ChunLei. This is the presentation of my project. This project is about analyzing the results of first, second, third, and fourth ICCMA. The project supervisor is Dr. OdinaldoRodrigues. First, the content of this project. This is the content that I will go through today. Let's start from the introduction of the project. ICCMA is a competition that aims to nurturing research and development of implementations for computational models for argumentation. The first competition was conducted in 2015 and every 2 years since. This project will answer these 3 questions shown in the slides, and this project aimed to analyze the results of the 4 iterations of ICCMA and present an overall trend of the competition results and some correlation between the solver's performance and the instance properties from the first to the fourth ICCMA. Let's talk about the background of this project. This project introduces some definition of extension-based semantics. Here I only listed the argument semantics that will be analyzed in this project, which are complete semantic and the preferred semantics. There are other semantics in the competition as well, such as stable semantics and ideal semantics. There are 4 reasoning tasks in each iteration of ICCMA, which are SE, EE, DC, and DS. And each year has different number of argument semantics in the competition. Therefore, the number of problems with semantics in total in each iteration of ICCMA is different. These tables summarize the reasoning tasks supported by solvers from 2015 to 2021. For the rules, each solver has 10 minutes to solve an instance. For each instance, a solver gives 0 to 1 points if it delivers the correct result. In the EE tract, a solver receives points depend on the percentage of the solver's answer. A solver gets -5 points if it delivers an incorrect result. A solver gets 0 points if a timeout or out-of-memory result come up. For the dataset, there are 2 datasets in this project. One is the instance dataset. This is provided by the project supervisor. Another is the competition result data. This can be found in the ICCMA official website. For the related works, there are 2 research papers are related to this project. This project extended some concept in those papers. For example, the result analysis by domain in the second research paper. Let's talk about the methodology of this project. So this is the methodology overview diagram. To answer the questions mentioned previously, there are 2 main parts of the methodology. The first part is instance analysis. 3 parts of analysis will be done here. First is to find the correlation between the instance domain and the instance properties. Second part is to evaluate the distribution changes in the instance properties from 2015 to 2021. The last part is to find the correlation between instance properties and runtime and between instance properties and solved instance percentage in each tract. The second part is the competition result analysis. This project analyzes the complete semantic and preferred semantic. This project analyzes the competition results by instance domain and without instance domain. For the results analysis without domain, this project analyzes the result distribution, solving time, and memory usage with only correct answer. For the result analysis by instance domain, this project analyzes the instance solved percentage, and remaining are the same in the without domain analysis. Alright, let's take a look at one of the results after I've applied the methodology. Note that due to the time limit of this presentation, I will only demo some plots, but we'll go through all the result analysis. For more details, please refer to the project paper. To find the correlation between instance domain and instance properties, heat map are created. The scale of the correlation is from -1 to 1. The lighter the color is, the more positive correlation between instance domain and instance properties are. In summary, the domain GRD correlated to the same instance properties, which are average non-trivial size and maximum strongly connected component size in 2015 and 2019. For the distribution changes in instance properties, this project uses cumulative distribution function to show the distribution. The y-axis is the proportion, and the x-axis is the range of numbers in the instance. Each color represents different year. Generally, this project found that in 2017 and 2021, there is a wider distribution range for some instance properties. For the correlation between the instance properties and runtime in each track in both semantics, heat maps are created as well. In summary, in all the tracks except in the EECO and EEPR tracks in 2015 and 2021, the instance properties average non-trivial size and maximum strongly connected component size and density in those tracks could be good indicator of runtime. There are the correlation heat maps between the instance percentage and instance properties as well. The conclusion of these analyses is that for all the complete semantic tracks in 2021, the instance properties, density, and total layers are positively correlated to the solved instance percentage. However, in 2019 and 2017, most of the instance properties have no obvious correlation with solved instance percentage. Bar charts are created to present the result distribution. Y-axis is the percentage and the x-axis is the year. Each color represents different instance solved results. In summary, the potential reason causing a high proportion of timeout results in the EEPR, EECO, and DSPR tracks in 2021 could be that many newly designed instances were added that year. The proportion of incorrect results and other results are decreased year by year. For the average runtime with correct answer, line plots are created. Each line plots, the x-axis represents the year, the y-axis is seconds. The average runtime is in orange, the median runtime is in blue. Overall, both semantics in all the tracks except in the EECO and EEPR tracks, the slowest runtime is in 2021, the fastest runtime is in 2019. Line charts are created to present the average memory usage. The x-axis represents year, the y-axis represents memory usage, and the unit is bits. The orange line is the average memory usage, and the blue line is the median memory usage. Only 2019 and 2021 have the memory usage column in the result data. Overall, you can find that the average memory usage in both semantics in all the tracks in 2021 is lower than in 2019. These tables show the solved instance percentage in each domain in each track from 2015 to 2021. When NaN is shown in the table, means no such domain in that year. And these projects bought the highest and the lowest solved instance percentage. This solved instance percentage by domain is in the preferred semantic. Overall, an interesting trend is that in both semantics in most of the domains, the solved instance percentage increased on the following year, indicate that solvers perform better in domains in previous ICCMA iteration. These tables present the results of runtime in each track in the preferred semantic. The domain identifier ER and WS has very low runtime in 2017 in most of the tracks, but became very fast in runtime in 2019 and 2021. This is the average memory usage table by domain in the preferred semantics. The domain GRD in the SEPR and EEPR tracks has the greatest memory usage in 2019. The domain 2021 other domain has the greatest memory usage in 2021. Move on to the conclusion and the future work. In the beginning, these projects list 3 questions. The answer to the first 2 questions are shown in the slide. The answer to the third question is in the slide as well. There are 2 suggestions to the competition. For the objective of the first suggestions is to test whether the solver performed better or improved the solving ability or not. The reason for the second suggestion is because in 2021, a very high proportion of results were timeout, so if the competition could give solvers more time to solve the instances, then the competition may find those solvers who have the ability to solve the new or hard instances. For the future work, one thing could be done is to find out why no correlation between solved instance and instance properties and runtime in 2017 and 2019. Another thing could be done is using the instance properties to classify the difficulty of the instance and analyze the competition results. This is the presentation of these projects.